All right, good day and welcome to Everything Mathematics. Today we're going to do a special series, or rather this week we're going to start a series on factorization and let's see where we go from there. So what is our objective for today? Today we're seeking to first of all understand the whole concept of factorization. We're going to talk a little about what factorization is all about. And last but not least, we're going to list the common ways we factorize algebraically. So in maths, usually when we are asked to factorize, usually, more often than not, algebra is involved. But factorizing is not all about algebra. But let's see if we could make a marriage between the two. So, what is the big picture when it comes to factorization? I like to see factorization as a vocabulary word, which it is. Think about words like legalization, maybe, or liberation, or what again? I can't think of any other word. But the sation part of the factor simply tells us that it's a process of doing something. So if we're talking about legalization, it's a process in which we try to legalize something, make something legal. When we talk about factorization, that is the process involved to make a factor or to find a factor. Good? So simply put, we could say that factorization is a process of finding the factors to a number, and in bracket here I have something, because whatever we factor in does not have to be a number, but it could, but you don't have to. And thus I have something. But then, if we know factorization is the process of finding a factor, then the other question comes, what is a factor? What is a factor? So let's see if we could define that too. A factor is a number, and again in brackets something, because it's not only numbers we could factorize, and we will see that when the algebra step in. A number or something that can fit perfectly into something or another number. In the case of a number, it leaves no remainder. So that's the best way to look at a factor. Let me see if I could put that in my own words again. A factor is basically a number if we're dealing with a number. A factor is a number that could fit into another number without a remainder. And try not to mix up factors with multiples. Multiples is a whole different story. Let's leave multiples there. So a factor is a number that could go perfectly into a number without leaving a remainder. So let's see if we could explore that whole idea a little. I'll first use numerics and then we're going to use algebra just a little. Today shouldn't be a long video. So numerics. Supposing I ask you for the factor of 32. When I ask you for the factor of 32, there's basically one thing I'm asking you. I want to know the numbers that could go into 32 perfectly. And to tell you the least, there is no one strategy or one way I know this could be done. But one of the ways I know it could be done is this way. You identify two numbers which you could multiply and you get 32. So once you could get 32, you get in a factor. And from there, you just break down. So here I have 2 and I have 16. And I know these are factors because 2 times 16 is 38. But then 16 has its own share of factors. So for 16, for example, I could have 2 times 8. Good. Then I have 8. 8 also have its share of factors. For 8, I have 2 times 4. And then last but not least, I have 2 times 2. And of course, each 2 here could break down to 1. So if I want, I could go 1 times 2. But I wouldn't go there because 1 is a factor of every number in the world. That's one thing we should know by now. So once we get a prime factor, basically we could stop. And then I introduce a new term there again, prime factor. And prime factors are basically the lowest set of factors that you could get from a number that will give you back that number. So if, for instance, I go to multiply all these prime factors together, I should get back my number, my original number. And you could see it. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that's one of the ways in which you could factorize a number. What I just did here, I call that factorization. And this process of factorization would lead to finding out the prime factors of a number. If you take this approach, when you finish, at the bottom, you have what you call your prime factors because there are no other numbers that could find or that could get you these same numbers here. Of course, you could use 1, as I said, but 1 times anything is the same thing. So even if you go to put 1 times 2, you will still end up with 2 5 times, and the ones will, when you multiply 2 by 1, it's still getting 2, so it doesn't change anything. Good? So that's the process of finding your prime factors or factorization. When it comes to the algebra, the concept is the same. So for example, you might have x squared, and I could ask you to factorize x squared. What do I mean when I wanted to factorize x squared? I'm just looking for, I wouldn't say a number now. No, I would use something, because here we're dealing with algebra. The x could stand for anything, so allow me to use something to represent it. Now I have to find something that could go into x and leave no remainder. And that's the whole process of factorizing. So if I want, of course, in this scenario, I could easily use x squared, since it's the only variable, and that will leave us with just the 1. And the whole thing about factorizing is that when you go to reverse the process, you have to end back with what you started with. So of course, if I multiply x squared by 1, I will get x squared. Somebody might cancel out a x. If you take away a x from a x squared, and let me put this another way. Remember, x squared, and we have to understand a little about indices here too. X squared is the same thing as x times x. So if you go to cancel out a x, it's like you just take out one of the x's, and that will leave you with, again, in bracket xx, which again, if you go to reverse, you will get back your x squared. And this is just a generalization. You see, I don't want to go into the specific strategies because that's what we're going to be doing for the entire week, this week. However, what I need you to understand that the process of factorization is simply finding a factor of a number or something to a number that will leave no remainder. So for this week, this will be our focus. We're going to factorize using various strategies. And these are the strategies that we're going to highlight starting as of tomorrow, God's will. We're going to be looking at the HCF method or the GCF, which is the highest common factor or the greatest common factor, followed by factorizing by grouping, then factorizing by using the difference of two squares. Then we're going to look at the AC method, and I make my only disclaimer. I don't know if this strategy is named the AC method, but I refer to it like that. If it has a different name, I'll be glad to know in the comment section below. Then, of course, you have the quadratic formula. And last but not least, my favorite one, we're going to be doing completing the square. So these are the various strategies, at least for CSEC. These are the common strategies that you need to know. There are others that also plays a role. For example, when we're dealing with trinomials and even when we're dealing with perfect squares. Maybe I could touch perfect squares after I finish this series, because it's important to understand how to factorize a perfect square. What is the result of a perfect square? Because usually they expect us to reverse this process. They don't usually ask us to factorize using perfect squares, but they usually present us with a perfect square, but we need to understand how does that fall back to come or to become. So we're going to be looking at all that in time to come after we finish these 6 strategies. So again, that will be the end of today, and this is just a recap, not even a recap, it's just an introduction for what we're going to be covering for this week. So if you gather nothing today, I need you to understand at least this one thing. Factorization is the process of finding the factor of a number or something. And when it comes to algebra, there are several strategies that you need to be adept with in order to factorize. And again, by factorize, I repeat, you're finding the factor that could go into that whatever equation, number, whatever the case might be. So you take care, and until tomorrow, God's willing, we're going to be looking at the HCF. See you.